Okay, within this doodlecast, I'm going to wrap up hypothesis testing with the z-test. And so we're going to walk through a couple of examples, and then we're going to talk about power. And this should conclude the lecture topics for Chapter 7 so that you can complete your hybrid as well as Chapter 7 homework. So the first thing I want to do is show you this example. The first thing that we want to do is try to find the important information that we need. So first of all, a sample of 16 employees, we know that's our n equals 16. I gave you the population mean, population standard deviation, as well as a sample mean. And it's asking, do the sample of 16 employees package more product than the average population? So we're using alpha 0.05, and this more suggests that we're looking specifically for a one-tailed test. So we know that we need to use this as a one-tailed test because of the word more. So in our hypothesis testing, we have 4 steps. The first step, as we move to the next, is stating our hypotheses. The reason this is the first step is so that we can look at our research scenario and decide whether it's one-tailed or two-tailed. And so if we go, we can see, they're stating, do the sample of 16 employees package more product than the average population? Basically, that hypothesis is stated in there. It's just in a question form. So we're going to, regurgitate it into null and alternative hypotheses. So that null hypothesis is basically your statement that something is not going to change, something is not going to increase, something is not going to decrease, whatever it is. So I'm going to state it as the sample of employees will not package more product than the population. So there's your null hypothesis. It will not. Your alternative is basically the same thing, just that it will. The sample of employees will package more product than the population. Now we just finished basically our step 1 of stating the hypothesis. The key is, a couple of things here are key. We have, our direction, which is key. And we have a statement of saying what's going on. So basically, packaging product is our dependent variable. So this is what we would consider our dependent variable. Okay? Whether or not they are a sample or population is our independent variable. So we have our direction, and we have our independent variable and our dependent variable in there. Could be quasi-independent variable as well. So that's key within your hypotheses. So is setting the criteria. Now we know that our alpha equals 0.05. right? And we know that it was one tell, and it's stating that we're looking for more, right? Them to package specifically more product. So you need to look in your unit normal table. So in your textbook, it starts at page 477. Now with one tell test, we're going to put all of that 0.05 into one tell. And we're going to be putting it in this upper region, okay? Because anything that falls in here is significant. So this is 0.05 here in the tell. So we're going to look up 0.05 in the tell, and we're going to find our Z critical value. So when you look up 0.05 in the tell, I usually just go to the closest as possible. So I used 0.0505. I'd be okay with 0.0495 as well, but typically the standard is a Z of 1.64. Positive 1.64, because we're looking at an increase. So that's what it means by setting the criteria. That would be your answer for setting the criteria for a one-tell test. 3 is calculating the test statistic. Okay, we need to go all the way back to the first information. I do remember the N was 16, right? We need to get our mu, which is the population mean, our standard deviation, as well as our sample mean. So I'm going to go back and put those in. If you go back to the slide, you can look as well. So now that I have all of the information that I need, I can actually calculate the test statistic. So we're going to use the Z test, which is M minus mu over the standard error of the mean. And remember, standard error of the mean is the standard deviation of the population divided by the square root of the sample size. So we end up plugging it in. It's 700 minus 650 divided by 80. That should be an 8. 80 divided by square root of 16. So when you calculate that out, be careful about your order of operations when you're entering in the calculator. I usually put parentheses around the numerator, then I divide, and then put parentheses around the denominator. But you can do it piece by piece if you'd like. So you should be ending up with 2.5. That's your test statistic. But we're not done. In this step 3, when it says calculate the test statistic, we should be calculating an effect size as well. And basically, when we are talking about an effect size, we're looking at basically the standard distance that your sample shifted compared to the population. And to get an effect size, we're going to use Cohen's d. So Cohen's d is basically very similar to the z equation, but it's just the standard deviation in the denominator instead of the standard error of the mean. So we end up with 700 minus 650 divided by 80. So when you calculate that out, remember to use your order of operations when you're plugging it in your calculator. You should be getting D equals 0.625, okay, or 0.63, which is officially how it would be reported. Now, if you look in your PowerPoint slides under Cohen's d, or in your textbook, table 7.6, you'll know that a Cohen's d of 0.63 is a medium effect size, a moderate effect, meaning that whether or not the person was in the sample or population had an effect on the number of products that were packaged. That's really all that that means. So we have those test statistics. This is interesting though, because on step 4 we need to determine whether or not we have significance, right? And before we do that, I'm going to just draw this out. If you remember, our Z crit was 1.64. Anything that falls out here is significant. If you look at our Z obtained of 2.5, we're going to come down here, it's falling, you know, like way over here. So it is significant. So now we need to find what the p-value is for 2.5. And all we do is look again in our unit normal table under the Z column, column A, and look for 2.50. And then go over and look for, in column C, the proportion or probability value. You should be getting, I'm going to put it in a different color so that you know, for this, I'm going to put a little arrow, P equals 0.0062. I'm doing it really crooked, but we need this for when we write our APA statement. That's 0.0062. That should be a 0. 0062. Let me write that a little bit better. I'm running out of space. P equals 0.0062. We found that by looking up our Z obtained in area C in the unit normal table at the back of your textbook. So now we can actually write our APA result. Step 4. So we did find significance, right? So we're going to write, basically, if we find significance, we're rejecting the null. And we can basically restate our alternative hypothesis with our statistics included in the APA format. So I would write the sample employees packaged significantly more product than the average population as Z equals 2.50, that's our obtained test statistic, P equals 0.0062, and alpha equals 0.05, one-tailed, with D equaling, what was our code? 0.63. And that's the end of your statement. Key things that need to be included. You again need to state whether it was significant or not, whether what direction it was significant in. Your independent variable, your dependent variable, your Z obtained, not your Z critical value, your Z obtained, your P for the proportion or probability of where Z falls, your Z obtained falls, your alpha, whether it's one-tailed or two-tailed, and your size of effect. These all need to be included, and they have to be in this order. This is APA format, and this is the order that has to be followed. So let's try one other, a little bit different. So that was a one-tailed test, but here's how you recognize a two-tailed test. Your two-tailed test will look something like this. So now they're just saying a significantly different. That's vague. We're not sure whether they're looking for an increase or decrease. It's vague. So we know that we're going to be using a two-tailed test. So alpha equals 0.05 two-tailed. Then we're going to move on to step 1 of hypothesis testing. This is all the same information. The only thing that changes now is our hypothesis about, and our, how we set up our criteria. So how we go about deciding whether something is significant or not. So now we're going to use the two-tailed. So we're going to write our hypotheses. They're going to be similar. So the sample, employees, will not differ in product packaged. Just a way to summarize it. Packaged compared to the population. Notice, will not differ, and differ is the key word. We're not stating one way or another. The alternative is just the opposite. The sample employees will differ significantly in the product packaged. Oop, and I even spelled it wrong up here. Oh no, I didn't. I just wrote it differently. And I'll put packed again. Compared to the population. So now you're just looking again at differ. And that's really the key when we're dealing with a two-tailed test. So step 2 of this, again, is criteria. So we're going to use alpha equals 0.05, and we're going to use two-tailed. So this is a major change in the steps, because here we have our distribution, and we're going to split 5% into both the tails. So over here is going to be half of 5%, and over here is half of 5%. So basically over here is 0.025, because 2.5% is half of 5%. Over here we're going to have 0.025. So when we look in our unit normal table, now instead of looking at 0.05 in the area beyond Z, you're going to look up 0.025. Now be very careful, because it's very easy to lose track of decimals. So when you look up 0.025, you should get a Z of 1.96. Now be careful, because that should be negative and positive. So your final answer should be Z critical value equals negative and positive, whichever way, 1.96, because we're dealing with two-tailed. So that's the key difference within a two-tailed versus the one-tailed. So step 3, reading the statistic again. Nothing changes with that. We know when we calculated everything, we got a Z obtained, which equaled 2.50, and we got a Cohen's d, which equaled 0.63, just like the last time. All of the calculations is exactly the same because the statistics and parameters did not change. So all of that is exactly the same. But if you'll notice, the p-value will change. So now we're going to look up a p, and when you look up 2.50, just like you did last time, 2.50, you got 0.0062. Well, because we're dealing with a two-tailed test and we're dealing with z-scores, we're going to multiply that times 2 so that we can get our true p-value. But I'm not worried about that. You do not have to do that. All you need to do is just give me this p-value, because this is the only time in any hypothesis testing where it will have you account for a two-tailed with a p-value. And so I'm not worried about that. I just want you to provide me the p-value that you find within your textbook. So you don't need to worry about finding something different. If you did multiply it times 2, I'd be perfectly fine with that. And you would end up with 0.0124. But don't worry about that. Just give me the p-value you find, because this is the only time that will change. So now we could actually make our decision. It's going to be different though, because if you remember, now we're dealing with different critical boundaries, negative 1.96 and positive 1.96, right? So our z is still significant, right? Because our z falls within the critical boundary, right over in here. So we still have significance. Just a couple of other things changes, like our alpha level and critical value of how we're getting those. So now we can go ahead and state or write our decision in APA format. So I'll write sample of employees packaged significantly more product than the population as z equals 2.50, p equals what was it, 0.000062, alpha equals 0.05. Now it's two-tailed with d equaling 0.63. Everything's the same except for now you're stating your test is two-tailed. That's key. It's really the only thing that changes. And it's very important that your APA format stays in this format specifically. So now we're going to go over a couple of things related to power before we wrap up. So power is the likelihood of rejecting the null. So how likely is it that you're going to reject the null? Power is directly influenced by three major things. As Cohen d increases, power will increase. That likelihood of rejecting the null. Because Cohen's d, or an effect size, is basically the absolute magnitude of your effect. So how much your mean differs from the population, your sample mean, the standard average. As sample size increases, your power will increase. And as alpha increases, your power will increase. So basically, if you move your alpha level from 0.01 to 0.05, your power will increase. And I'll show you what this looks like. So let's look at this distribution. Here we have this distribution, and let's say we have our cutoffs right here, and we're doing a two-tailed test with alpha equals 0.05. That means our z is 1.96 and negative 1.96, correct? Now, if we were to do a two-tailed test at 0.01, if you look at 0.01, or split actually 0.01 in half, you're going to look up 0.005. So, and that's specifically in the area beyond z in the tail. So if you look at 0.005, I'm looking at about, I'll say 2.58. Okay, I'll say 2.58. Here's where it would be, basically. So we have 2.58 and negative 2.58. And here we are at alpha 0.01. Well, here's an example. If you're looking to reject the null or find significance, it's going to be easier with 1.96 because there's all of this room, a lot of room, a lot more room. You have 5% between both sides. But if you're using 0.01, which is less than 0.05, then you're limited to just this room, these edges out here, which shrinks it. So there's less proportion in the tails, making it more difficult to find significance. So you're going to have power with a less stringent alpha level, such as 0.05 rather than 0.01. So this gives you a visual, basically, of how power works, and hopefully that will help. Now you should have all the information you can to complete your hybrid, probably even more information than you needed, and you probably had to zip through some of it, but that's fine, as well as completing your Chapter 7 homework. And we'll see you next week.